Ever stop to think about how this, the human ear, actually gets made? It's an absolute masterpiece of biological engineering, and it starts its journey from nothing more than a simple patch of cells. So today, let's dive into that incredible story.
I mean, just look at this thing. It's an intricate machine that handles both hearing and balance, all packed into this tiny, tiny space. So the big question is, how does our body build this, starting from practically nothing? That's the mystery we're going to unravel today. All right, so here's our game plan. We're going to tackle this in 5 main parts. We'll start with that very first spark of development. Then we'll see how the inner, middle, and outer ear get built piece by piece. And finally, we'll touch on just how fragile this whole process really is.
Okay, let's kick things off right at the very beginning. You know, the path from just a couple of cells to a fully functioning ear isn't random. It's a precisely timed sequence of events, and it all starts way earlier than you might think. Seriously, the speed here is just mind-blowing. As early as week 4, the initial blueprint for the ear appears. Just 2 weeks later, the external ear starts taking shape. And the wildest part? By week 26, the fetus can already functionally hear sounds inside the womb. That's just incredible. So, where does this whole incredible story begin? It all kicks off with something called the otic placode. And really, it's nothing fancy. It's just a little thickened patch of cells on the ectoderm, which is the embryo's outermost layer, right there on the side of the developing head. That's it. That's the seed for everything that's to come. All right, now let's get into the nitty-gritty, the inner ear. This is actually the first and the most complex part to form. I mean, this is where we get the advanced machinery for both our sense of hearing and our sense of balance. So, how does it start? With a simple fold. That flat, otic placode we just talked about starts to push inward or invaginate. It creates this little dip called the otic pit. This is a huge first step because it's moving the whole structure from the surface to deep inside the embryo. Okay, and then comes the real magic. That pit keeps getting deeper and deeper until, bop, it pinches off completely from the surface. What you're left with is this little hollow sphere called the otic vesicle. And this tiny ball of cells, that's the foundation for the entire inner ear. From that humble little sphere, something absolutely incredible starts to take shape. It grows and twists and differentiates into this super intricate structure, the membranous labyrinth. This is basically the delicate, soft tissue housing for all the sensitive gear of the inner ear. And what's so cool is how this one structure cleverly divides up the work. The top part, the dorsal portion, that's going to become our vestibular system, the thing that keeps us balanced. Meanwhile, the bottom part, the ventral portion, that's what forms all the structures responsible for hearing, like the all-important cochlear duct. So, you've built this incredibly delicate piece of machinery. Now you got to protect it, right? Well, the surrounding tissue, the mesoderm, starts to harden and form a bony casing. This creates the bony labyrinth, which is filled with fluid, allowing the membranous labyrinth to just float safely inside. It's like a built-in biological shock absorber. So, the inner ear is taking shape. Now let's look at the middle ear. And this is where it gets really fascinating, because its parts are essentially borrowed from other structures that are busy forming the head and neck. Yeah, the key players here are something called the pharyngeal arches. These are basically bars of tissue that show up around week 4. They're the fundamental building blocks for a ton of stuff in your face and neck. And, get this, in a wild throwback to our deep evolutionary past, these are related to the very same structures that become gills in fish. So you might be wondering, where do these smallest bones in your entire body come from? Well, right here. Those 3 tiny ossicles, the malleus, incus, and stapes, are all formed from the cartilage found inside those first and second pharyngeal arches. Let's break that down. The malleus, or the hammer, and the incus, the anvil, they both come from the cartilage of that first arch. The stapes, or the stirrup, well, that comes from the second arch. It's just an amazing example of our bodies being super efficient, repurposing these ancient embryonic parts for totally new jobs. And it's not just the bones either. The actual space they live in, the middle ear cavity, along with the eustachian tube that connects your ear to your throat, that also develops from an inward fold of these same structures, called the first pharyngeal pouch. Okay, on to the final piece of the puzzle, the outer ear. This is the part we can all see, and how it gets its unique shape is a pretty amazing biological sculpting job. Check this out, because this transformation is just incredible. Around the 6th week, these 6 little bumps of tissue, called the auricular hillocks, just appear. And then over the next few weeks, these 6 simple mounds start to fuse, fold, and grow, basically sculpting themselves into the complex, unique shape of the external ear that we all recognize.
While all that sculpting is happening on the outside, a groove starts tunneling its way inward to form the ear canal. Now at first, it's a solid tube of cells, but eventually it hollows out, creating that perfect pathway for sound to travel all the way to the eardrum. So we've seen how the inner, middle, and outer ear are all built from different tissues, almost like separate construction projects happening at the same time. This complexity makes the entire process incredibly delicate and, well, pretty susceptible to disruption.
I mean, think about it. You've got these 3 totally separate parts that have to develop on their own and then link up perfectly. There are so many points along the way where things can get off track. And when that happens, it can lead to a whole range of congenital conditions. A really clear, visible example of this is a condition called microtia. This is what happens when those 6 auricular hillocks just don't develop or fuse together correctly. The result is an external ear that's either really small or not fully formed.
And other things can happen too. For instance, you can get little skin tags near the ear, which are basically leftover bits of hillock tissue. Or if the ear canal doesn't hollow out properly, you get a blockage called atresia. And sometimes, those tiny little bones in the middle ear can actually fuse together, which stops them from vibrating and can cause hearing loss.
So there you have it, a 22-week journey, all the way from a single layer of cells to a symphony of sound. The story of how our ears are made is just one of these countless, incredible developmental sagas happening inside of us. It really makes you stop and think, what other hidden stories of our own creation are just waiting to be told?